In this video, we're going to talk about simplifying rational expressions. And rational expressions are that word ratio in it, they have a fraction in them. And the one thing we want to keep an eye out in rational expressions is that denominator, because we never can divide by zero. Remember, the line in a fraction just means divide. So we have to keep an eye on what value would make this expression, make the denominator of it zero, which would make the expression undefined. Those are sort of our danger zones as we go through these. So here's a rational expression where the top and the bottom are already factored out. And we're trying to say, is there any way I could simplify this? And then in a minute, we'll talk about those danger zone things that would make this undefined. So first of all, if you think back to just simplifying a fraction like 10 over 15, where we just have whole numbers, we can rewrite this as 2 times 5 and 3 times 5. And then we know that 5 divided by 5 is just equal to 1. So this is that big invisible 1. And multiplying by 1 wouldn't change the value. That's why we can cancel those 5s or divide by 5 on the top and bottom to simplify this down to 2/3. We're going to use that exact same idea, but now we're using it with variable terms instead of constants, instead of those just numbers. So I'm just going to rewrite the bottom for a minute. Remember how 2 times 3 is the same as 3 times 2, so the order of these two multiplying factors doesn't matter. And now I can see on the top and bottom I have an x plus 5 over an x plus 5. Those divided are just a big secret 1, a very wide one this time. And so those can cancel right out, and I'm left with just x plus 4 over x plus 2. I had a factor being multiplied into the top and multiplied into the bottom. It's the same factor, so I can cancel it out. Thinking back to those restrictions, this is just an expression, so we could plug in infinitely many values for x, but there are two that would break this. So let's take a look. If the bottom was equal to 0, so either this was equal to 0 or x plus 2 was equal to 0, then this expression wouldn't work. So we really cannot plug in -5 or -2. Those are our values of x that would make this undefined. So we could plug in anything else for x and evaluate this at, x equals 3, x equals -4, but we can't evaluate this at x equals -5 or -2 because it would be undefined. Looking at this rational expression, we have x minus 4 times x plus 5, and on the bottom, x minus 5 times x plus 1. And these look pretty similar, but they're not exactly the same. So I cannot cancel an x plus 5 with an x minus 5. And if you're ever trying to double check, is that going to work or not? Just plug in any value for x. So if I plug in 1 for x, 1 plus 5 divided by 1 minus 5 is definitely not equal to 1. So I can't cancel those out. I actually can't simplify this anymore. It's exactly as simple as it can get. And then coming back again to always checking, when is this undefined? Just because I couldn't simplify it doesn't mean I shouldn't check when it would be undefined. It would be undefined if x was 5 or if x was -1. Those values will not work for x in this expression. Now here, it looks a lot like what we had before, but it's a little bit different. So let's talk about this for a sec. On the top, I have x minus 4 times x minus 5. And on the bottom, I have 5 minus x times x plus 1. So the thing we're really worrying about is this x minus 5 and this 5 minus x. What's the deal with those? And just like before, we can pick a value for x to plug in and kind of play around and see what happens. And if we start to notice a pattern, then we're going to want to test that out. So I'm going to plug in 1. And I would have 1 minus 5 over 5 minus 1 is -4 over 4, and that makes -1. Let's plug in 2. On that, I'm going to have 2 minus 5 is -3 over 3, and that's -1. Well, this is interesting. Let's plug in -10. -10 minus 5 over 5 minus -10. -15 over +15, also -1. So now I'm really noticing a pattern, and I want to double check. is this always going to be -1, like no matter what I plug in for x? So let's think for a quick second about greatest common factors. Because when we have, say, x minus 4 and we have 2x minus 8, these do have common factors in them. And let's look at why. This guy is equal to, if I took out the greatest common factor of 2 times x minus 4. So x minus 4 and 2 times x minus 4 both have that x minus 4 factor in them. We just maybe couldn't see it immediately from right here. So let's look at that same idea with x minus 5 and 5 minus x. 5 minus x, I'm going to do one of those sneaky math teacher tricks and pull out a greatest common factor that I know is going to work. And so I'm going to pull out -1 because there's really no other common factors here, right? It's like 1 and -1. There's nothing else. 1 isn't going to change anything. Let's see what happens if I take out -1. So I divide 5 by -1, I get -5. I divide minus x by -1, I'm going to turn, that becomes a plus x. And then, in the same way that 2 plus 3 is equal to 3 plus 2, I can rearrange that. And now, that looks a lot like my x minus 5. In fact, it is my x minus 5, but with a -1 multiplied into it. So, let's take a second and come back to this problem. Just this part can turn into, if I cancel those common x minus 5s, it becomes just 1 over -1, or it just becomes -1, right? So I can turn this into, factoring out that -1, I can just cancel these x minus 5s now, as long as I don't lose track of that -1. And now I have x minus 4 over, you could write it like this, -1 times x plus 1. You could just put the negative out front. Again, just as long as you're not losing track of it, you could distribute it back in however you like. But that x minus 5 and 5 minus x cancel to a -1. Thinking back always to when is this undefined, we know that x cannot equal 5 and x cannot equal -1 because those values cause us to be dividing by 0 in the original expression. And the simplified expression does look different, but we want to make sure we're keeping track of it from the original one. That's going to help us when we are getting into rational functions. Last thing before we move on, that x minus 5 over 5 minus x being able to cancel to a -1, that happens a lot. It's a really nice rule, and we're just going to make sure we know that rule because it's a nice general rule that works all the time when you have something that looks like a minus b over b minus a. So here's again what we did in order to factor out that -1, right? I had b minus a, and I divided out a -1, which switched the signs, and then I just reordered them. I just said, -b plus a is the same as positive a minus b. So that b minus a is equivalent to -1 times a minus b, which is how I'm canceling those out. But you can also just remember the shortened version, which is this rule right here. A minus b divided by b minus a is always going to cancel to -1. If you're not a person that finds it easy to kind of memorize these rules, you can always come back to factoring out a greatest common factor. It's just that -1 as a GCF is not maybe a natural one to remember unless you've been doing a lot of these. All right, let's take a look at this one. I've primed you for it. You're ready to rock because we are looking for a greatest common factor that would allow us to cancel something, just like we did with x minus 5 and 5 minus x. Because right now looking, we don't have anything identical top and bottom. But this looks interesting because it looks like there has a greatest common factor in there. So let's take out 2 and turn that into an x minus 2. And then if I leave everything else the same, I now have a factor that's being multiplied on the top and multiplied on the bottom. Cancel it right out, and we should be able to simplify this guy down. Coming back to when is this undefined, x cannot equal 3 and x cannot equal 2. those are the values that would make these equal to 0, and that denominator cannot be equal to 0 or everything's going to break. No dividing by 0, friends. So when you sit down to simplify one of these, make sure to factor the top and factor the bottom if you can, and look to see if anything cancels. Factoring could mean that you're just taking out a greatest common factor, or it could mean that you've got a quadratic, you're going to use the AC method to get it down to binomials. Use this lovely rule. It's going to help you when it comes along. So here's a practice one. Let's look at that top, that numerator, and look for a common factor. It looks like 3 and x go into both of those. So if I divide those out and see what's left, 3x squared divided by 3x leaves me an x. 9x divided by 3x leaves me just 3. And now I've got x plus 3 over x plus 3 cancels right out, and I've just got 3x. On this one, the top is the same. How nice of me. I'm going to save my work from before and say the top is still 3x times x plus 3. The bottom now, let's talk about how we're going to factor that quadratic. On my ax squared plus bx plus c, I need something that multiplies to 1 times 3, so 3, and adds up to 4. And my two numbers that do that are 1 and 3. Because a is 1, I can just break that out. But remember that if my a was not equal to 1, I would want to make sure that I wrote this out and then factored by grouping. But here we are. Since my a was 1, it was easier than that. I've got an x plus 3 multiplied on the top. I've got an x plus 3 multiplied on the bottom. This is 3x over x plus 1. Now, let's see, we've got one already that where a was not equal to 1. In the numerator of this fraction, I've got 2 times negative 9, so my AC is negative 18, and I need two numbers that multiply to negative 18, but add up to negative 3. So looking through my options, I think I'm going to want positive 3 and negative 6, and I'm just going to do a little side problem to factor that guy, because I do not want to accidentally factor that guy wrong. I'm going to take my sweet little time to make sure I do this guy correctly. I think I can take a negative 3 out of that, right? Nice. So the top is going to turn into 2x plus 3 times x minus 3. If you're ever not positive, if you factored it correctly, remember, you can just FOIL it back to make sure it gets to where you wanted it to be. On the bottom, I need two numbers that multiply to negative 3 but add up to negative 2. That sounds like x minus 3 and x plus 1 to me. So now I can cancel my x minus 3's. So nice. And I end up with 2x plus 3 over x plus 1. Last step, I am going to factor that top. Two numbers that multiply to negative 5 and add up to 4. Sounds like x plus 5 times x minus 1. And on the bottom, I need two numbers that multiply to positive 15 and add up to 8. I'm going to do x plus 5 times x plus 3. These guys cancel, boop, boop, right out, and I have x minus 1 over x plus 3.